Hey, it's Dave Cooper, and we are back with another episode of Product Spotlight. And we have the awesome Sam Rubin on.
Hi, great to be here, Dave.
Buildings. I love this. This is going to be so much fun. Sam and I were talking offline. I'm already excited because, Sam, you just have so much excitement in your voice with your product and everything you're doing. But first, listen, I want to thank everybody that's joining us. If you're just joining, please hit that like and share button. Sam, we are on 3 channels right now, Facebook, LinkedIn, and YouTube. So please check out and subscribe to our YouTube channel, and also subscribe to Mighty Buildings YouTube channel. They're going to be putting some really cool stuff up there. So with that said, Sam, thank you so much for joining us today.
Really appreciate the opportunity, Dave.
Yeah, this is going to be a lot of fun. I mean, who in the world wakes up and says, you know what, I'm going to 3D print buildings one day? Sam Rubin does, I suppose.
Yeah. Me and our CEO Slava and our other co-founders, Dimitri and Alex.
Yeah, for sure.
It's been a great journey, and really, really excited to finally have launched out stealth mode after 3 years of hard work.
Right. So where is Mighty Buildings located? Let's just tell everybody where you're at, and then we'll jump into how we got started.
Yeah, so our production facility is located in Oakland, California, not too far from the Coliseum here.
Okay, love it. All right, Sam. So like we were talking about, I want to know everything from childbirth up until this moment. 5 minutes. So
all right,
I got to know how somebody goes from your childhood birth into 3D printed homes to now you're out of stealth mode and the world's just an exciting place. Tell us all about it.
Yeah, so. Originally, I was born in Massachusetts, but I consider myself a Michigander, having moved to Ann Arbor when I was about 4 after a short stint in St. Croix. So lived there, grew up there in Ann Arbor, went to college at Vassar in Poughkeepsie, New York, where I studied political science and economics. Then after college, came back to Michigan, worked at the JCC for a while, went to New Orleans with the Red Cross for a couple months to help people recover there, and eventually made my way to California, where some friends got me a job actually as a beer buyer at a high-end natural food store, which was awesome, but not the most intellectually stimulating of all jobs. So moved into San Francisco from Sausalito, where I'd been, and got a job with United Religions Initiative, which is a really cool global interfaith peace-building organization that has a really powerful organizing model to bring people together across traditional barriers to meet their needs of their individual communities in a way that works for them. And that was great, and then got the pull to go to grad school. Had thought I was going to be a lawyer. I took the LSATs a couple times, did really well, and then one day realized I didn't actually want to be a lawyer. I just wanted to be able to walk through the doors that a law degree would open. And I'd knew about Presidio Graduate School from my housemate, who was one of my friends from Michigan, who was a student there, and knew from meeting his classmates and everyone that they were the kind of people I wanted to be in community with. And it's one of the first programs in the world to focus the entire curriculum around sustainability and systems thinking. So I went there and got a dual MBA, MPA, so a master's in business as well as public administration. And then after grad school, I moved back to Sausalito and took a job in Marin County with a small full-service design brand strategy firm, overseeing their operations and helping with the brand strategy side of things. And that was really, really great and really wonderful experience, but what didn't really involve sustainability as much as I wanted, as much as I felt called to. So decided to shift into sustainability coaching. And consulting. And so I was working with organizations, everything from small nonprofits to large municipal organizations and schools and everything in between, and helping them develop sustainability action plans, where they're looking at different programs to save water, energy, reduce waste, reduce the transportation of their employees, things like that. And so helping them model those, really understand what are the cost savings. Because at the end of the day, you can make a great case for sustainability, but it's hard, but if someone's not into sustainability, you need to be able to talk about it in a business sense. So I'd focus on the efficiency, improved efficiency of operations, increased productivity, cost savings to the bottom line. Oh, and by the way, you also have all this carbon savings and the sustainability story that you're able to tell to add that brand value. And so it was really great, and was doing a lot of work on building envelopes and building systems. So looking at identifying HVAC systems that need tuned, ways to reduce thermal leakage and issues like that, as far as like improving the windows, maybe providing additional insulation on the envelope. Right. And was doing that when our CEO Slava reached out to one of my former classmates. He was at the time running a VC firm in Singapore, I had worked with a classmate of mine at Indiegogo on a crowdfunding campaign for one of his other companies. And he reached out to her because he had this idea about how, because he kept coming to Silicon Valley and saw how we built. And he's like, this just doesn't make sense. We're still building using like 100-year-old technology. Why aren't we embracing new technologies as a way to help address the housing crisis? And so he reached out to her looking for someone to help with an understanding of the housing market, housing regulations, and sustainability. She posted on one of our alumni Facebook groups, and I responded, and the rest is history. And it was a good fit because my capstone at Presidio was my team put together a business plan to take clean virgin hospital waste, particularly that blue wrap, so that kind of blue cloth that's virgin polypropylene, and which normally is just going to landfill and is huge waste, and converting that into 3D printer filament. And 3D printing, I'm a huge nerd, so 3D printing has been a love of mine ever since I realized Star Trek replicators, 3D printers with energy modulation.
Right. Sorry, you froze up there for a second, but all right. So,
oh no,
holy cow, man! So, listen, it is so obvious how excited you are about this, and you know, let's hop into a little bit like, so with the 3D printing, let's talk about how you got together with a couple people. You sat down, you came up with this brainstorm of an idea, you wrote a white paper, and you said the rest was history. Tell us a little bit about what that white paper was, and let's move into to where you're headed. Because if you're just tuning in, we got videos. We're going to show you how these are printed. We're going to walk through the process. You're going to be able to ask questions on how it's insulated, how windows are installed, anything you want to ask Sam, we're going to be able to ask in this. And we're also going to be able to show you. If you are just joining, please hit that like and share button. All right, Sam, tell us about this white paper and about the partners and how this all got kicked off.
Yeah, so as I mentioned, Slava kept coming to Silicon Valley to raise capital and everything, and kept seeing this issue with housing. And so he realized there was a big problem. We connected, we worked out, we keyed in on 3D printing as a real opportunity, but we also saw that there were issues with concrete, like as far as cold joints, the fact that you need to still install insulation on the interior and exterior surfaces, the fact that you couldn't print the roof. And so that it was a great step, but that there was a lot missing. And so we put together a whole white paper on what a new system of printing could look like. And so working with the team that Slava had put together of researchers and really beginning to dive into that, develop that, and then being like 40, 50 pages, looking at all the different opportunities as far as in person or like on-site printing, which was where we were thinking originally, but then looking at the benefits of prefab and really being able to leverage all those plus the benefits of 3D printing. So increased quality control, ability to print throughout the year, as well as the ability to do post-processing that's just very difficult to do on site.
Right.
And so we were lucky enough to get into Y Combinator, which is one of the more prestigious tech accelerators here in the Bay Area. Really was huge honor for that. And then coming out of that, got funded by Khosla Ventures, who have been wonderful supporters of ours. And then we connected, during that time, we also connected with our CTO, Dimitri, who brought the printing technology that he'd been working on and developing. And that really unlocked a lot of what we were doing, because we had the concept, but then to add someone who actually had the material like work that he'd been doing with the UV curable and all that really opened things up, as well as our other co-founder, Alex, who had a background as an entrepreneur with robotics, which really brought in kind of the second half, that post-processing that really opens up the opportunities for what we can do.
Sure. So let's talk about the material. So it's not concrete. What is the actual material that you guys are using to do the 3D printing?
Yeah, so it's a UV curable thermoset composite, which is a mouthful. Most people are pretty familiar with Corian by DuPont, which is used for countertops and everything, is now used for cladding and other use cases. And that's probably the most similar, the most analog on the market currently.
Right. And how long, so with Mighty Buildings, so how long have you guys been in stealth mode?
So we were found, we officially incorporated in early August 2017. So it's been 3 years. We came out literally 3 days after our third birthday.
I love it. Dude, this is exciting. I can't wait to talk about all this. So why don't we let's hop into the details of this, right? So you guys are doing 3D houses, you're doing 3D, 3D homes, 3D ADUs, and then you also have some other products, some wall panel products and what have you. Tell us a little bit about your product line, and then let's jump into exactly what you do. Maybe we can start doing a little bit of show and tell, but not before we say hello to a few people. So go ahead, tell us about the different things you're building.
So far we started with the accessory dwelling unit market, so backyard apartments, granny flats, largely because it's an opportunity that's really been opened up under California state law starting in 2017, and with increasing loosening of the regulations at a state level, because the state really sees them as a way to address the housing crisis to increase density without really changing the nature of neighborhoods. And so it's also a space that allows us to build without really competing with a lot of the developers and builders who we see as our long-term customers. So far we've gone to market with the line of ADUs with our Mighty Studio, which is, as the name implies, a studio, as well as our Mighty Duos, one of which is a side-by-side 1-bedroom, and we also have a 2-bedroom version of that. And then what we call the Duo I, which is 2 of them end-to-end. It creates a nice long unit. Right. And so those initial units are hybrids. So they've got a 3D printed wall, which is the curve, combined with a traditional steel frame. And the reason we did that is because we wanted to make it easy for building officials to say yes. Building officials are understandably conservative. They're in charge of the safety of these homes. And so we wanted, this isn't software. We can't throw it out in the wild and debug it on the fly. So we have to make sure we're doing it right. And by going with this incremental approach, it allowed us to get to market faster while still building out our certification portfolio with UL, who's our certification partner, as well as under the state of California factory built housing program. And so so far we've delivered one of the studios to San Ramon, one of the Mighty Duo Bs to San Diego. And that one's cool because the owner originally was going to rent the ADU and live in his house, but he loves it so much that he's actually moving into that ADU and renting the house. So that's something that's got us really excited about how much he loves what we're doing. Right. And we've got a couple more ADUs that are ready to ship. We're just waiting on the site work to be completed. That's here in Hayward and Oakland, here in the Bay Area. And then another 10 to 15, I don't forget the exact number, projects that are lined up and are moving into production now. So and then next, yeah.
Go ahead.
Oh, and I was saying, and as you mentioned, the panelized system. So we've developed a panelized system called the Mighty House Kit. Right. We've got a couple base models, but the cool thing about that is it really opens up a customizable floor plan system that we can work, that serves really well with the build to rent market and developers and builders who might want to use it to unlock the productivity of their existing labor force. Because at the end of the day, that's what we're really trying to do, is right. Be a tool for industry to really allow labor, the existing labor, to build more. Because we're not building the houses we need to close that housing gap and address the affordability crisis. Yeah, so those panels will be fully printed. We'll be utilizing our material as the entirety of the wall, everything from the interior finish to the exterior finish, including the thermal barrier, fire barrier, air water barrier, vapor barrier. And so it really highlights what our material can do. It's kind of a SIP panel on steroids.
Yeah.
So those will be online next year once we finish all the certification tests.
Absolutely. So we're going to jump into that. Remind me to ask you as soon as we say, after we're done saying hello, and the question is going to be, do these sit on regular foundations, right? You said site.
They do.
I'm kind of curious. So we'll hop into that. All right. Let's say hi to a few people that are joining us today. Hey, we got Joel Hutchins, Splash Modular. Good morning, all.
Great. Good to see you, Joel.
Yeah. Hope all is well with you, Joel, over in Australia, I believe is where you're still at. We got Mark Willie on with us. In other words, on BS Friday, we call him Bare Naked Willie. So we're great to have Dave. Yeah, one of these days, we've talked about that. We're going to come out and we're going to live stream from one of Sam's locations, hopefully soon enough.
Yeah.
We got Shane McNutt from Nudo. Good afternoon. It's going to be an interesting topic today. Well, we're definitely driving some interest for sure. Look, we're all the way in France. We got Henry Mickelberg. Good evening. I'm not a fan of 3D printed structures unless it's part of a DFMA assembly, so I'm looking forward to being wrong. All right, we'll talk about that. We got the CEO of SIGA North America. Good afternoon. It is Etienne Gubler. Excited to learn more about the various printable materials. Moving down. Anthony Good, lead AP. Good afternoon, gentlemen. Nice to see you, my friend. George, look at all these people tuning in. You're a popular guy, Sam. We got George.
I think it's you, but
Phoenix, Arizona. You might know this one. We got Jerry McCahey. What's happening, Jerry? Good afternoon from the Emerald Isle. So Jerry's with Integra.
Nice. Great to meet you, Jerry. Thank you for the
yeah, he's part of the Housing Innovation Alliance. You guys, I'm sure, have crossed paths. Yep. You just don't know it. So, all right. And then we have George Ryman. How can we improve the finish of 3D printed structures so that builders and our customers do not require an additional step to improve the finish so the printed layers are not noticeable? So let's say
I did talk all about that.
Let's save that one. All right. So we said hi to a lot of people. We got through that. Let's get into exactly what you do. I think everybody's itching to kind of see what you do. So why don't you walk us through, where does the designs begin? How do I get started with you? Walk me through the process of building my 3D printed home with Mighty Buildings.
Great. So if you're just a homeowner, you can go to our website. We've got a variety of models. As I mentioned, we've got the studio and our duos, so a studio and 1 and 2 bedroom, as well as our line of Mighty House kits, which are based on the panelized system that goes from a 1 bedroom with a flex all the way to a 3 bedroom, 2 bath. And that larger one's actually a starter home rather than an ADU. We recognize that starter homes just aren't being built anymore, but there's increasing demand for them, particularly among millennials and Gen Zs, as well as baby boomers who are looking to downsize. And so right now you can select from our variety of designs. If you're a developer builder, we actually have the opportunity to work with you to develop custom floor plans using our panelized system. And so we're really excited about that opportunity to unlock that impact at scale and really help builders do more and increase their productivity and throughput, as well as reduce the time that it takes for them to get those units up and built, because the panelized system is going to be able to go up in less than a week. And so the process, once you select the design, and we work with our design team there, we're also developing a Revit plugin that's going to make it really easy for designers and builders to work directly with what we're doing and with our system. Right now, it's just the panelized system, but long term, it's really going to open up the opportunity to leverage the freeform design that we're able to do. Because one of the cool things about our technology is we can print unsupported structures and curves, so it really opens up a whole new era of what design can be. So once we have that, because we do fully digital end-to-end fabrication, so it starts as that design in Revit, that goes straight into our Slicer, which is the custom program. Well, Slicer is the general program for anything that converts a design into a 3D printable G-code. We've developed our own custom one. It goes into that, and from that, it goes straight into the printer. And what this means is that we're able to really identify, and we're also able to leverage simulation. So we can simulate a build thousands of times before we actually do the first build to identify any quality control issues, any potential bottlenecks. And it also means that because there oftentimes in a big project, there are design changes late in the process that can really add costs. For us, that's not a big deal. It's just a matter of changing the 3D model. Right. So it's really simple to do design changes that might come down from the planning department or whoever. That makes that really easy. And we don't have to reshift our entire production line because it just changes the software code, not the printer itself. So it then goes into the printer. The printers, if it's the panelized system, we print all those panels. If it's volumetric modules, we can print those. So we can do 350 square foot volumetric module in under 24 hours.
Well, why don't we do this? I know you have the software, right? Can we take a look at how? Let's start walking through the design and share some of this stuff and really take people down the journey, because I think the most important thing that I'm hearing so far is build it on the screen first, so it's accurate, done when and it saves you money on the back end. So why don't we walk our way through that with you?
Sure. So yeah, let me share my screen here and pull up that video. And I mean, it's gonna look really familiar because all we're talking about here is Revit. So let's see there. And so this is, as I mentioned, this is our plugin. And again, it's just Revit. So you're working directly in a system that most builders and architects are already familiar with. Really easy to incorporate custom panels, move your windows around, because we're not set, like we don't have to build a single panel size, where we really have the opportunity to create panels of different sizes, and that includes the corner. So we actually print the corner as a single panel to make that a much tighter seal and reduce the thermal leakage that often occurs with traditional panelized systems. But as you can see, we can move the windows around, drop new ones in. It's really, really simple process, and makes it really easy for architects to create custom floor plans using this system. And longer term, as I mentioned, it's going to get more complex and really bring in the opportunity to do curves, unique shapes, and really unlock that creativity that architects have, but in many cases haven't been able to really embrace fully because of how expensive it can be to do freeform design.
So let me ask you this: is there standard widths and lengths that you're trying to follow, or is it kind of the same as any other volumetric building for shipping reasons and what have you?
Yeah, so when it comes to the volumetric modules, we're not limited by the printer size. We're only limited by the by overroad. So we have to stop at about 11 feet tall to get under the 14-foot overpasses and try to. With the volumetric models, we did go slightly wide load, so we did go up to 14, just under 14 feet, but we didn't go above that because then it gets prohibitively expensive. You need 2 chip highway patrol cars, and with other in the future, we also have the opportunity to bring that down to 12 to streamline that even more.
And what is the framing of this? Like you said, the floor. What are you printing on to give you that structural rigidness that you need to ship down the highway?
Yeah, so we're actually just print our material. On the initial units, as I mentioned, we utilize a printed curved wall with a steel frame box. But for the units we'll be delivering next year, they're going to be fully printed, and it's going to be our material taking all the structural loads with some steel incorporated at key points for reinforcement, again, to make it easy for building officials to say yes. But with our new fiber reinforced material, all our internal testing indicates that it has structural properties similar to steel. And so we're really excited to do the certification on that with UL to really be able to demonstrate that in a way that goes beyond just our testing.
Right. So so everybody understands with that certification, in other words, it's just like volumetric building or modular, where you have a third party that certifies everything. So the building inspector on site doesn't ask you to cut holes in your wall to do an installation inspection. So
exactly. Yeah. So it's the design's approved by a third party. The inspections are done in factory. Right. And although with panelized, obviously that is inspected on site for the assembly. But one of the really cool things about our system is that it's not just printing. The printing is just the first step. So once it's done printing, then we have a couple robotic cells that leverage industrial robotic arms that have been widely used in automotive and other industries. And with that, we're able to automate. We're going to be able to automate the pouring of the foam insulation into the interior of the structure itself to increase that insulation. Currently, with a 6-inch wall, we can get an R value of 21 with open cell foam, and we'll be looking to move to closed cell and expect that to get to R30 or even more. And we're continually looking to how can we improve that. And along with the pouring of the foam, we're also able to mill the surface, because even though it's strong as concrete, it's soft enough that a CNC head can mill it. So actually, to go to Mr. Mickelberg's question, we can actually are able to do the entirety of the structure. And there was one other person who asked about the surface. And that's one of the really cool things that gets me excited is the design flexibility. It's truly a design agnostic production system because we can use the milling in order to create unique facade looks, make it really smooth stone-like finish, similar to Corian, or we can use it to mimic, say, brickwork or siding or other traditional architectural finishes in order to meet strict areas where there are strict architectural guidelines. We're also able to automate the surface finishing, so we can do spray up stucco, paint, and other traditional finishes. And one of the cool things is that the printed surface makes a really good scratch coat. So even when we apply stucco, we don't have to go through that whole process. We're able to just apply it directly. Same with paint and primer and paint. And so we're able to mimic traditional looks or create whole new looks that have never been seen before.
I love it. I love it. Let's get into it, man. Let's show people so they understand what you mean about adding robotics and putting insulation and using robotics and what have you. Go ahead and I'll put it up.
Yeah. So let me just go with the longer our brand story video. It kind of takes everyone through it. I think that'll be a good one here.
Yeah, and if the sound doesn't come through, just walk through it.
Totally. I've got share audio there, so hopefully we should be good. We go full screen here.
As building costs continue to rise, the dream of
audio
owning
coming
a
through for
home
you?
is out of reach for most people. 2025,
okay, great.
1 in 3 urban dwellers will struggle to have their housing needs met by the construction industry. Companies big and small are decentralizing as the new normal moves rapidly towards remote work and collaboration, requiring smaller, smart satellite workplaces. 4 visionaries from diverse backgrounds came together to completely reimagine the way we design and construct our homes and offices. Together, they wondered why the construction industry continues to build using archaic methods instead of embracing new ideas and technologies. And thus, Mighty Buildings was born to rethink what is possible, to fundamentally transform the way buildings are conceived and constructed in the 21st century. By scaling up 3D printer technology, then leveraging the best in automation and robotic fabrication, while using state-of-the-art composite materials, Mighty Buildings is emerging as one of the world's most innovative modular dwelling manufacturers. Mighty Buildings produces the first 3D printed structures to be UL certified by the prestigious Underwriters Laboratories. Mighty Buildings can currently 3D print a 350 square foot accessory dwelling unit, an ADU, in 24 hours or less, using 95% fewer labor hours, with 1/10 the waste and scrap of traditional methods. Their goal is to automate 80% of prefab operations and reduce build times by up to 90%. But 3D printing is just the beginning. They are already bringing robotics to automate exterior finishes and pouring of foam insulation. Unlike concrete, the composite material they use is lighter, more energy efficient, and can be machined and finished by robotic arms. Due to the unique nature of Mighty Buildings' advanced composites, which harden almost instantaneously, as well as the latest advancements in reinforcing material with continuous glass fiber, architects, engineers, and home builders will have the freedom to create spaces with spans and configurations that would normally require large steel and concrete reinforcement. This opens up a whole new dimension of possible design options. The Mighty Building design and production process leverages industry-standard software to connect design directly to the production process for truly flexible and seamless flow of digital fabrication. Imagine architects working from home and deploying their new designs directly to highly automated factories. It's time to reimagine the way we build. It's time to put into force the convergence of 3D printing, automation, and advanced material science in a mighty new way that puts people and the planet first. It's time to make a change. It's time for Mighty Buildings.
Love it. There's a whole lot to unpack in that video. There's a whole lot to unpack in that video.
Yep.
Listen, so just the way the machines print. So, I mean, that's incredible. You said it's 95% less labor.
Yeah, versus a traditional on-site build, because most of the most dangerous portions of the job, like the framing and everything, is all taken care of with that, as well as a lot of the finishing.
Right.
But at the end of the day, we're not trying to replace workers. What we're really trying to do is allow them to build more.
Right.
And so that's really our goal. Because at the end of the day, there's always going to be parts of the job that really make sense for humans to do. And we want to make sure that those are as easy for them to do as possible. And really, so then at the end of the day, it's not about reducing it. It's actually hopefully going to give them more work, just
right.
easier work. And so they get to work on more units.
Yeah. And so when that's actually pouring the walls or the floors or whatever it's doing, how is it? I mean, it almost looks like my kid's slime. How is it curing so fast so it doesn't just run off?
Yeah. So I think there's another video that works really, that I think I can show, the one I was showing you before from early on. Yeah.
It all comes together.
So this is just a short one, but let me do this here. And so this is a while ago. This was actually when we first started, and we're still on a desktop printer. But it really highlights what we're doing. And so we're actually able to print up to 250 millimeters a second now. But for production, we're stay between 120 and 150. But what's happening here is that the UV light that's hitting it as it's coming out is triggering a polymerization reaction that actually hardens the material instantaneously, allowing it to support its own weight, but also allowing it to achieve full cohesion with the next layer. So when it's all said and done, we actually end up with a monolithic structure that we can print in unique forms and shapes. So that's one of the things that I find super exciting about what we're doing, and it is really key to the concept.
So it's hardening as it spans, and then what are like the weight load properties of this? Like what's the tensile strength of how far you can span and things of that nature?
Yeah, so my understanding from my engineers is with our current technology, we can get up to about 14-foot span.
Wow.
With unsupported. And so that's, really excited about that. So it has the ability to print the roof, like as you saw in one of the clips there with the video, and I can show the fully printed shell that we've done. That whole roof is going to be completely unsupported. And so that's one of the really unique things, and that it unlocks that versus say concrete 3D printing at this point. Because where concrete's kind of limited to, if you're doing the roof, it's going to have to be a dome or something where you're building. Ours, we can do fully flat straight across.
That's incredible. Up to 14 feet with no structure underneath it. Yeah. So, all right, let's get into the finish of this, right? So we have the structure. That structure is done in half the time as traditional.
Yeah. Yep, we're able to do a build in half the time of a traditional build.
Half the time in traditional
and,
build.
and about 45% less cost than comparable homes, and about 20 to 30% less than traditional prefab for comparable homes as well.
So prefab already touts that they can be less than traditional site built. You're saying that 3D printing is going to be 20 to 30%, give or take, less at a comparable build as a volumetric or prefab home.
Correct. And a lot of that's because what we're doing with our wall, as I mentioned, is it's the entire wall. Everything from the interior finish to the exterior finish. And so we're eliminating the need for a lot of that additional finish work that happens on a traditional prefab structure.
Right, right. So walk us through the finish. I know Henry was asking about the finish material. So do they require any exterior cladding?
Once we're complete our sort of additional testing of this fall, we're going to, because so far we have a Class A flame spread rating on it, but we haven't done the testing to do the fire rating. But we're fully anticipating a 1 hour fire rating and likely a 2 hour fire rating. And there's an outside shot that we can get a 4. We actually did an internal test. It was just a quick and dirty test where we put a gypsum board on a 2x4, put some of our equivalent thickness of our material on a 2x4, put a torch on them. The gypsum board burned through after about 13 minutes, and the wood was burst into flame. We turned the flame off on ours after about an hour and a quarter.
Yeah.
It had gotten 5 millimeters in, which we were able to just scrape off, add some more material, hit it with the UV lamp, and it was good as new.
And fixed. No kidding. So all right. So I'm going to keep just plugging away here because I have a ton of questions. What about windows, doors, wiring, plumbing? How does all this work in a 3D printed structure?
Yeah. So with windows and doors, it's just a matter of printing the channels, and then we can also use the robotic milling in order to mill those out to the exact tolerances needed for the assembly. And then we just attach them like you normally would into a traditional structure. As far as wiring and everything, so we actually are leveraging prefabricated MEP cores to really make that easy, because that really speeds the assembly. So we're able to drop those in directly, and that consolidates the bathroom and the kitchen, a lot of your complex MEP systems. And then for switches and everything, we're able to use wireless switching. And initially, we're looking at a baseboard system for the wiring, as far as for the traditional loads. But longer term, in our phase 2, we're actually going to be able to embrace the full power of BIM, because we can take that BIM model with all the chaseways and everything and be able to print those directly into the panels themselves. Right. So that there's not a need to be spending. So when your electrician comes on site, you're not paying your most expensive person to spend a day drilling holes. You're paying them to do what they're good at, which is making sure the wiring is done and everything. And we're also looking at in factory being able to put in harness wiring systems, so that when you get panels on site, it really is just plug and play.
Right, right. I love it. Let's get to some comments here real quick. Let's say hi to some more people. All right, we have Jose joining us. Looking forward to learning more about the thermal properties of their printed materials. Why don't we touch on that? You want to talk a little bit about thermal properties of it?
Yeah, so our material is about 4 times as insulating as concrete, and with that 6-inch wall on the video where you saw that curve with the sine wave and the foam inside, that wall with the open cell foam is able to achieve an R value of 21. And we're going to be, with our panels, moving from that open cell to a closed cell foam, and we're fully anticipating getting to an R30 on that. And we're also looking at additional high efficiency insulation foams that we can utilize to be able to truly make it a high efficiency panel and potentially even get to R40 or higher. So we're really excited about that aspect of it.
Yeah, R40. And what is the thickness of the exterior wall, you said?
6 inches. So it's currently the 6-inch wall has a R21, but our goal is to get to that high efficiency to be able to qualify for some of the benefits of that when it comes to achieving passive house, as well as California's zero net energy standards. And that's part of why we started in California instead of somewhere like Texas, because Texas is great. You can do anything, which is awesome, but it makes it hard to then move into other states and move into other markets. And so by starting in California, which has some of the most stringent regulations in the country, particularly around energy efficiency and environmental impact, we're able to easily move into other states, which is one of the, because to quote JFK, we choose to do this not because it is easy, but because it is hard. And because of that, it really, it makes the longer term roadmap easier, because at the end of the day, we're not trying to do 1 or 2 units here and there. We're really trying to do 3D printed homes at commercial scale and really serve as that tool and as a vendor for industry to allow them to create their designs using our system and maximize the value of that labor, given that we're seeing shortages in skilled labor across the board. And because we're using cutting edge technology, it's also an opportunity to introduce a whole new generation of workers into the industry who currently might be going into programming or other work because they're interested in technology. But this gives them a chance to come into the construction sector and really have a chance to still work with that cutting edge technology.
Well, yeah, I mean, you're still building. You're just using computers to do it.
Yeah.
Which is really cool, and it's exactly what our industry needs. I think
21st century solutions to 21st century problems.
Absolutely. I 100% agree. 100% agree. All right, let's keep going through some of the comments here. So, Miles J. Biggs ideas. He's digging my jacket today. Hey, listen, it's a party. We're coming out today, right? Listen, 3D.
It's a launch party.
Mighty Building. So it's a party. Sam said the cake's in the mail. Love it. All right, we got Tom Reddy. Tom Reddy's from Synergy Steel. What's happening, Tom? Thanks for joining us. We have Daniel Small. Hey, Dave and Sam. Huge fan of 3D printed structures. I think it's the next step in industrialized construction. Has a real shot at finally solving the global housing crisis. Love it. Love it. Thank you so much. YouTube, Jared Gross. Awesome dive into the Mighty Buildings project. Thanks for hosting this live, Dave. I subscribed and look forward to your future work. Well, great, Jared. Let us know what you're up to out there as well. We'd love to learn more. Keeping on. The most popular rock.
All right.
I'm not sure what that is. Maybe you do.
Maybe some dubiousness at what we're doing, but hey, hopefully I can dispel that.
Mark says, nice video.
Oh, thank you.
That was a good video. Joe Hutchins, are you interested in licensing the seller technology? I see many uses here. Also, software-wise, we should talk.
I would love to speak to that. Because as a part of, I've been talking about how we want to be a tool for industry. And one of the cool things about our system is that we don't need super large facilities like the 1 million square foot or hundreds of thousands of square feet, like you see with a lot of these larger prefab builders. We can set up a single production line in less than 3 to 6 months, and it takes up less than 10,000 square feet. For example, our initial pilot facility was 7,500 square feet in the shared warehouse in Redwood City. Now we're in a 79,000 square foot facility in Oakland that's going to allow us to deploy 5 to 10 printers and multiple robotic cells. And so that's one of the really cool things, is that we can take advantage of idle warehouse space in near where the demand is. And so our goal is really to partner with builders and developers and put these printing hubs all across the country and all across the world where there's demand. So we're not only producing housing for a market, we're also creating jobs for that market and really reducing all the logistic costs and the travel and the transport, and really making it as efficient as possible to get as many units built as we can.
Sure. And so how many units do you think you can actually put out in a year, a month, a quarter? Have you guys really looked at it and done the study on what you can actually be running out the door?
We can. We're going to be able to do 20 production facility that we can set up in 3 to 6 months. We're going to be able to produce 25 to 50 building components per day, depending on the complexity of each part.
Yeah.
Yeah.
I'm sure this material in the 3D printers just aren't something you go to Best Buy and pick up when you need to build a production facility. How does that process go? And is it proprietary to you guys, the way these are set up?
It is, yeah. So the core of our IP is the material production process, as well as the printing process and the printing technology. So the printer and everything is custom built, custom designed by our team, as well as the material. We've developed it and patented that as well. And so it's a unique formulation that we've developed that basically takes it's similar to Corian, but different in that we've created a way that we can actually 3D print it. And so that's something we're really excited about. And we're also, one of the cool things is with the milling, we're able to capture that powder and use it in new material as a filler. So we're really focused on that zero waste production and the recyclability. And we're actually even looking at what does it mean to be able to recycle a unit at the end of its lifespan, after 30 or however many years. I mean, we've tested the material after 73 years, simulated 73 years, and only lost 10% of its structural properties. So it has a potential to last a really long time. But we want to make sure at a point when the homeowner does want something new or wants to build a new one, that we're able to take that and make sure that we're not just sending that to landfill and adding to the waste that comes from construction, like the 3 to 5 pounds per square foot on traditional builds.
Right. And I just re-say it again. What was the total waste that you have?
Oh, so for us, it's close to zero waste because we're able to capture the powder that we mill, and the 3D printing process prints only what's needed. Yeah. Without having to get the right cut, and then you've got this weird piece that you never use, so that gets tossed. So we're eliminating that 3 to 5 pounds per square foot of a traditional build. So
I order one of these 3D homes, ADUs from you. I'm the general contractor. Walk me through how much work I have left to do on site. What's the process once it comes out of your manufacturing plant? I got my foundation in place. You said it's a normal foundation. I'm assuming I could have a hole in the floor if I wanted a basement and put stairs in.
Yeah, you could do that. We could, although with our studio, with the volumetric modules, that'd be a little difficult.
Okay.
But with our Mighty Kit home, that would definitely be doable. And we've also designed them to go on a variety of types of foundations depending on the needs of the area. Because here in California, you get a whole variety as far as being on hillsides, different types of soil. So it can go on pier systems, it can go on slab systems, it can go on curtain systems. So when if it's a volumetric module, it's really, really straightforward. It gets to site, we drop it on. If it's a one module, you just weld it or bolt it to the foundation depending on the needs of that site, and you're good to go. If it's multiple modules, it's a matter of bringing them on site, attaching them, and doing that welding. But it's all really straightforward. With the panelized system, we're designing that to the IKEA easy. So it's really about making sure that any general contractor can easily set it up. And so for that, it's just about, and we've also designed those panels to be able to go through backyards, because again, the Mighty House is designed initially as a large ADU, small single family home. So if it's an ADU use, we can use a telestrator. So you get into that backyard, and it's made to be able to be lifted and moved by forklift or basic stuff like that without a crane, whereas the modules do require a crane.
Sure.
But it's a matter, you're able to stand them up, connect them all. Initially, it'll be mechanical connections with utilizing a light gauge steel frame. Long term, in our next phase of material, we'll be eliminating that, and it'll actually be a chemical, it'll be adhesive. And so we'll be using that to create the seal and create a monolithic shell that eliminates thermal bridging and really makes a really tight envelope. And once it's on there, then you install the MEP core, which contains the bathrooms and the kitchen. We're able to run pre-harnessed wiring, as I said, through the either baseboard initially or eventually actually through pre-printed channels throughout the system, as well as the plumbing. That'll be additional testing we'll be doing with UL to certify it for those use cases. And it's going to be really easy. The goal there is to be able to set one up in less than a week.
Less than a week on the foundation, bring my furniture in.
Yep, and the Mighty House kits are intended to ship in intermodal containers. Yep. So with everything you need, including the windows and everything else.
So with that, the windows installed or windows ship loose?
To be determined.
To be determined. Got it. Okay.
Likely loose, because on the initial ones, we're actually in court for those panels. It's going to be a traditional panel for the windows, but while we continue to develop the technology, but longer term, as I said, it'll likely ship within the already installed in there, because we'll trimmed all the channel, printed the openings, and then trimmed the channels to the exact tolerances. Yeah.
I love it. Tom Reddy, I know we touched on this a little bit. How do the MEPs fit into the walls? Specifically like heating, cooling, air conditioning. How is that going to work?
Yeah, so as I mentioned, we're leveraging prefabricated MEP cores. So we really kind of looked at the shipbuilding industry, which is actually light years ahead of the U.S. residential prefab market when it comes to modularization and prefab. And so we've actually borrowed that concept, and so we're using prefabricated bathroom units that then plug in. And then, as I mentioned, initially we'll be running the wiring and the plumbing, the wiring, because there won't be any need for plumbing in the walls, through a baseboard system that attaches, and then longer term leveraging BIM to actually print all those chaseways directly into the wall at wherever they're needed, and be able to run pre-harnessed wiring through that then gets attached on site, really plug and play. Yeah,
I love it. Absolutely. I think every home should be built with a core. I mean, quite honestly, just efficient wise, it just makes sense. All right. We got some more. Danny Small. What's your approach to insulating your enclosures? We talked a little bit of this already. And what are the thermal properties of the printing material itself? So not necessarily the 6-inch wall. What is the material itself?
Yeah, I don't remember the exact number off the top of my head, but it is about four times more insulating than concrete. So it performs rather well just by itself. And one of the things that we're looking into long term is what might it look like to be able to print air gaps, so that we can leverage kind of some of the latest in insulation in that regard.
Yeah. Love it. I love it. Well, listen, man. I mean, this is pretty cool stuff. What's the next step? What are we expecting from Mighty Buildings here moving forward? Yeah,
well, as I said, we just launched out of stealth mode last week. Less than a week ago. It was Wednesday. Well, actually, exactly a week ago. It's Wednesday. It's been that kind of week.
It's been busy, I'm sure.
Yeah, so people can go. So we're loving it, getting some great traffic at our website, www.mightybuildings.com, which you can see there. And also would love to be able to check out our youtube.com/c/mightybuildings, where you can see some of the videos I showed here, as well as testimonials from our first couple customers and videos of those builds. And so we're really excited about moving forward with our these current ADUs, continuing our certification with UL and with the state of California, as well as other states in Q4 and Q1 of this coming up here, to be able to start delivering our panelized systems with that exterior and interior surfaces. Well, initially it'll probably be just the exterior, and we'll still use drywall in the interior. Right. But longer term, we'll be certifying it for that interior use also as well. And so with these panelized systems, we have our base kits that people can order for themselves. But we're also excited to be starting to engage with developers and setting up some 2 to 3 pilot projects next year with some big builders in order to start deploying these into the field at scale, with the goal of getting to the point of having some multiple printing hubs around the country to be able to serve these different markets efficiently and be producing custom panelized systems for home builders, or volumetric modules, or small components, really whatever they need. Because at the end of the day, what we're really offering is a truly design agnostic and product agnostic production system that incorporates the latest in Industry 4.0, from digital fabrication to fully integrated quality control, to simulation, and everything in between.
Yeah. You know what, you have, and I was just thinking about your panelized system before we go, and I just want to tell people on your YouTube channel, you have some people actually sitting there hitting with a sledgehammer to show the actual strength of that panelized wall system, which I think is, I mean, you guys aren't hiding anything. You're showing it. Here it is.
Yeah. Let me show you this video of a couple of my co-founders going at, and this is one of our new fiber reinforced panels. Yeah. Without any insulation or anything inside. And so you'll see there's a little bit of damage, but compared to like what it would happen if you were doing this to a traditional wall, it's kind of amazing. So let me share this real quick. There we go.
All right.
So this is that's our CEO Slava behind it, and that's our CTO Dimitri swinging the hammer.
I love it.
And so that always gets me really excited. Here, I just love it so much. I'm going to show it twice. It just gets me excited about and as you can notice with the new fiber reinforced version, we're also able to reduce the material usage, and so increase the material efficiency of the product by eliminating a lot of those sine waves and replacing them with a much fewer number of just cross beams.
Right. Right. So I love it. So we got 3D printed homes, 3D printed ADUs. We got 3D printed panelized wall systems that you guys are working on. You're out of stealth mode. So listen, I think this is going to be a big hit. I think I think people should really take a hard look at this, especially when you look at the 95% labor savings. You look at being, 30-40% less than, traditional volumetric modular building, just
20-30 on traditional,
20-30 on volumetric,
45 on traditional construction on site.
Those are big numbers when you take that across the board.
Yeah. Well, it's really, the construction industry, there was a McKinsey study a few years ago. The construction industry loses out on $1.6 trillion in revenue annually due to inefficiency. Yeah. And that's what's driving our housing affordability crisis. That's going to be impacting 1.6 billion people by 2025. And so we really saw this as an opportunity to embrace new technology, the latest in technology, to help the existing labor force do more, to really close that gap, because that's the only way we're going to bring down these sky-high rents that we're seeing here in California, and we're starting to see across the country and across the world. We just need more housing, and we see this as a great way to get there. And in doing so, we really believe in disruption through collaboration. It's really about working with the existing industry rather than trying to displace them or kind of drive them out. It's about working with them in order to unlock their abilities, because we know what we're really good at. We're really good at printing and material, right. But we're excited to partner with builders and developers who know their local markets and know the entitlement process and know their planners. Because if you come in and you accidentally piss your planner off, you're not getting anything built. So for us, it's important to have those local partners who know the area and who have their own designs or who want to use our designs, and to really allow them to get those units out and get people in those homes faster. Yeah,
for sure. Well, listen, Sam, I appreciate it. Really do.
Yeah, well, really thank you for the opportunity, Dave. It's great to get to chat with you. Really enjoyed the conversation.
No, this was great. I really do. Hopefully, when everything clears up, we get out there and we can do some more on-site live, because I could only imagine watching these things print live has got to be amazing.
It's pretty cool. And when you see the printer, like you're looking up, it's on a scale that, according to UL, it's apparently the world's largest light-based printing system.
Oh, really?
Yeah, it was really cool. I was excited to hear that. And we're also, and speaking of UL, we're also excited to have worked with them to develop. They've developed now a new standard, UL 3401, for use of 3D printing in construction, and that's based on what they did to evaluate us. And the reason we chose UL versus say ICC or Atmo is that UL not only has the experience in building safety, but they also have experience in additive manufacturing, and so they had the expertise needed to really understand what we're doing.
Right.
To be fair, it meant breaking down a bunch of their silos internally and bringing like 7 different departments together, which was fun. But we're excited to have brought that forward. And we're also working with ASTM on development of their new standards for 3D printing construction, because we really understand that, again, this is housing. These are roofs over people's heads, and safety is paramount. And so we need to be making sure, if we're driving innovation, that we're also driving the regulatory and standardizations that are going to allow us to people to see and understand the safety of what we're doing.
Right. Right. Well, listen, I got a world of people that I want to introduce you to. Joel's somebody that you definitely should be talking to. And I have some others that are doing a lot of research on this. And I think in the higher education world that you should be talking to as well. So
cool.
We'll connect after this. But hey, Sam, listen, hang tight, everybody. This was a great product spotlight. I love it. We're looking forward to seeing what more comes out of Mighty Buildings. I'll be waiting for my piece of cake in the mail for our party, at least the party hat. But Sam, listen, Mighty Buildings, you guys rock. Your whole team's been great to talk to and work with, and we look forward to having you back on the show in short order here, because I think you're going to be very successful very quickly.
Thank you so much. And thank you to everyone who joined. Really appreciate all the great comments and questions.
Yeah, absolutely. So that's it, everybody. Please like and share this video. Please go to Mighty Buildings website, go to their YouTube channel, follow what they're doing. If you want to be at the state of the art of high innovation and you want to know what's going on in the world of construction, Dave Cooper Live is where we do it. And people like Sam Rubin and his team at Mighty Buildings are taking it to the next level. Everybody on this show, Sam, is invite only. It's not paid for. So I really appreciate you taking the time out of your busy schedule. That's it, everybody. Have a wonderful week, or what's left of it, and we'll see you. We'll see you tomorrow. I'll be back tomorrow. Thanks, Sam.
Thank you, Dave.